Hello! Today in the lesson we will solve some more examples in which we will write an infinite decimal periodic fraction as an ordinary fractional number. And the first example is 1.369 thousandths in the period. As we see in this example, the three digits in the period they repeat. We then have to write it down in the following form. First, we're going to write one integer separately, which is 1 whole plus 369 thousandths. How do we note it? Let's write it down as 0.369 thousandths in the period. Now, we're going to leave one integer untouched and we're going to write 369 thousandths as an ordinary fraction. And now, first of all, we're going to notice at the time when this period is written down. I mean, right after the decimal point, we have a period. This allows us to convert this entry to a fractional number immediately. And I write down 369. Numerators and the denominator has as many nines as there are digits in the period. And there are 3 digits in the period. So the denominator is 999. When solving this example, first divide the numerator and denominator by the same number. The result is 1 plus 369 and 999. These two numbers can be divided by 9. Why? To do this, let's remember the signs of divisibility. If I add the digits in the numerator, 3 plus 6 is 9, 9 plus 9 is 18, and 18 is divisible by 9. And at the same time, in the denominator, 9 plus 9 plus 9 is 27. 27 is also divisible by 9, so both the numerator and the denominator are divided by 9, and then the result is the following fraction. 369 divided by 9 is 41. And 999 divided by 9 is 111. And now we can find the sum. 1 whole and 41, 111. That's 1 whole, 41, 111. That will be our answer. Next example. Now once again, we'll solve the example where the period is written not immediately after the decimal point. For example, I'm going to take 0 integers but I'm going to take 0 integers so that we can do the math faster. Because if there's an integer in this entry, we write it down as a summand. Now let's go back to our example. 0 integers, 5 tenths and 6 hundredths in the period. As we can see, the period doesn't repeat immediately after the decimal point. Therefore, we must move this decimal point. To do this, we can multiply by 10. If you have 2 digits after the decimal point, then you multiply by 100 and divide by 100. If you have 3 digits after the decimal point that don't repeat and you have a period after it, then you multiply by 4 and so on. Let's go back to our example. 0 whole, 5 tenths and 6 hundredths in the period. Let's move the comma. Let's start by rewriting it. 0 whole, 5 tenths, 6 hundredths of a period times 10. But if I'm multiplying by 10, I'm also dividing by 10. Now once again, pay attention to the fact why I'm multiplying by 10 after the decimal point. And before the period, we only have 1 digit. That's why I'm multiplying by 10. If there are 2 digits in this case, I will multiply by 100 and divide by 100. Let's keep calculating. In this case, we have a comma shift. The result is 5 whole and 6 tenths in the period divided by 10. And in this case, we realize that 5 whole 6/10. Let's write it down separately. 5.6 in the period. I talked about it at the beginning. 5 point I write down. I'm left with 0.6 in the period, and that's 5 ones plus 6 ninths. See? And that's 5.6 ninths. Then I will write it down. 5.69 I need to divide by 10. 5.69 divided by 10 is very easy. But first, let's divide 6 and 9 by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. The result is 5.2 We can convert to improper fractions. 5 times 3 is 15, and plus 2 is 17 thirds. Now divide by 10 or multiply by 1/10. The result of this action is the following: 17/30. So our answer is 17/30. Let's write it down. 0.5 and 6/100 of a period is 17/30. Pay attention and you'll never make a mistake. That's all for today. Goodbye. See you again.